Hello, let us consider a block of mass m is lying on the surface, let's say on a table. A man is pushing this mass along this direction. So force is applied along this direction. So there is frictional force between the table and the block. Now in this video, I will first draw the free body diagram for this mass, which is relative motion with this table, and I'll calculate frictional force. This is on a horizontal table, so pushing a body on a surface. So this is moving, so the frictional moving along this direction. So frictional force is opposite to the direction of motion at the point of contact. So frictional force is along this direction. Frictional force is along the direction FF. Now it has weight. Weight is mass times acceleration due to gravity, which is acting down towards the earth center, and its normal force is acting perpendicular to the point of contact, so N. So we know that the frictional force is proportional to normal force, so which is F is equal to, if it is in motion, so let's say kinetic coefficient of kinetic friction, mu k times N. Now we have to find out N. N is unknown. To find out the frictional force. Yes. So in this video, in this picture, actually the mass, there is no relative motion in upward and downward direction. So the normal force should be equal to mg, equal and opposite. So that's why there is no net force on mass m. So there is no relative motion in vertical direction. So if I use this value in this equation, so you will get mu k times mg. So this is frictional force. So if a box is on a horizontal table, horizontal surface, if it is moving horizontally, then its frictional force is mu, coefficient of friction times its weight, mass times acceleration due to gravity. Let's say if a body is in vertical direction, so it's an inclined plane. So in this case, the box is moving down on a surface. The truck is unloading a box, so it is moving down. Okay, it is going down along this direction. So the frictional force should be along this direction. Yes, opposite to the direction of motion. So if I look at there are two forces. One is frictional force opposite to the direction of motion, and next one should be its weight, which is along the downward direction, m times t. So I have to calculate normal force to calculate the frictional force. So normal force is always acting perpendicular to the surface. Okay, so which is along this direction, perpendicular to the surface, perpendicular to the inclined plane. So I do have freedom to take the axis. So I'll take perpendicular direction is x-axis, and along the inclined plane downward is y direction, positive y direction and positive x direction. So motion direction is positive x-axis, and normal direction is actually positive x-axis. Yes, I can choose other way also, it doesn't matter. So I have to calculate the force of this mg along this direction and perpendicular to this direction. So let's take this triangle, okay, this triangle over here, this triangle. So which is theta over here. Yes, so that should be 90 minus theta. Okay, so this angle is 90 minus theta. So if I draw a line along this direction, then that should be my theta. Yes, because this is 90 minus theta, so whole total is 90, so this is theta, so angle theta. So in my trigonometry and component of vector, I also drew actual. Let's say this is vector mg, yes, and this is one direction, this is another direction perpendicular to it, and this angle is theta. Then how do you calculate x component? Let's say, okay, now x component, this angle. So if I know this value, which is hypotenuse, and I have to calculate base, so the relation is cosine. Okay, cosine. So let's say it's x component, let's say ax. Now relation between this and this is cosine. So cosine theta is equal to ax divided by mg. That means ax is equal to mg cosine theta. So wherever direction of theta is over there, in that direction the component is cosine component. So along this direction is I do have mg cosine theta. So other components should be along this direction is mg sine theta. If you remember, is vector component. So this direction should be, which is perpendicular to this, so that should be mg sine theta. So if you look at along the direction of motion, so frictional force is over here and mg sine theta along the direction of motion. So normal force, and along this perpendicular to the direction to this inclined plane, there is no motion. So I do have this two forces should be equal and opposite. So n should be equal to mg cos theta. So that means their sum is equal to 0. So there is no relative motion. But along this direction there is relative motion. Okay, relative motion. So to calculate frictional force, I do have relation F is equal to, if it is in motion, mu k times n. Okay, so I do have n is mg cosine theta. Yes, so that's why we can calculate the frictional force. Now if I want to calculate the motion along this direction, so there is motion along the inclined plane. So I do have along the inclined plane, I do have mg sine theta is one force. Another force is F, frictional force. Now mg sine theta is along the direction of motion of y, positive y. So this is positive value. So F is opposite direction of y. So this should be negative. So sum of them should be equal to resultant force. So if I want to calculate acceleration, then F is equal to ma. This is mg sine theta minus F is mu k mg cosine theta. Now if you know this angle, and if you know this frictional coefficient between this block and this inclined plane, and if you know the mass of this block, you can easily calculate how fast this block is going down.